Welcome to this video. Let's shatter a myth.
A myth right out of the gate, okay? Mathematics is absolutely not just endless memorization or boring equations trapped on a dusty chalkboard. In fact, what if I told you that the math you learned in school barely even scratches the surface?
Here is the crucial point. Mathematics is a highly dynamic, totally invisible force. We're talking about the structural backbone powering our modern reality. It's that silent partner in your daily routine, secretly working behind the scenes on everything from the food you eat to the music you stream. And the sheer scale of this, it's mind-boggling. From the smallest subatomic particles to the swirling vastness of entire galaxies, mathematics is the universal language that actually explains the cosmos. Equations like Einstein's E equals mc squared, they aren't just abstract symbols, right? They are literally the code dictating how the universe operates. It's pure power, precision, and infinite possibility.
Section 1. Math of a play.
Think about this wild juxtaposition for a second. What does a perfectly composed, highly emotive musical melody have in common with the harsh industrial reality of global shipping logistics? I mean, at first glance, absolutely nothing. They seem like entirely different worlds. But beneath the surface, they are speaking the exact same mathematical language.
As it turns out, the emotional impact of your favorite song is strictly governed by math. Fractions dictate exactly how long a musician holds a note, whether it's a quarter note or a 16th note. Time signatures divide the music into measures, but the real magic happens in the harmony. Simple numerical ratios, like 3 to 2, create what's known as a perfect fifth harmony. So without even realizing it, your favorite rock stars are actually just executing brilliant math equations.
But hey, it's not just art. It's in our physical play as well. In sports, athletes are unconsciously acting as high-speed human calculators. Geometry, trigonometry, and spatial awareness give these athletes a massive strategic advantage. When a soccer player curves a free kick, their brain is subconsciously crunching really complex geometry and equations of trajectory in real time to pull off a winning strategy. It's incredible.
Section 2. The Invisible Global Grid.
Remember that cargo ship we discussed a minute ago? Well, to move millions of tons of goods around the world efficiently, global supply chains rely entirely on something called graph theory. This is a mathematical tool that models routes and connections as complex networks of nodes and edges. Basically, it's destinations and the overlapping routes between them. By using this specific math, logisticians can predict traffic patterns to guarantee that your package lands on your doorstep overnight.
You want to know what's really wild about these tools? It's where they actually came from. If we look back at the history of pure mathematics, people often wandered off into the mathematical wilderness just out of pure curiosity, guided mostly by aesthetics. They invented abstract concepts that really didn't seem to do anything useful at the time. But then, say 100 years later, someone working on modern global logistics discovers that this obscure, centuries-old pure math theory is exactly the key they need to solve today's real-world problems.
A perfect everyday example of advanced math in action is the GPS right there on your smartphone. Every single time you use maps to find a coffee shop, you're relying on multi-satellite trilateration. Here's how it works. Satellites in orbit transmit signals down to Earth with a highly precise timestamp. Your phone measures the tiny delay in that signal. Because we know the speed of light, the math simply calculates the distance by multiplying that speed by the delay time. By doing this with multiple satellites simultaneously, it pinpoints your precise three-dimensional position anywhere on Earth.
Section 3. Predicting the Unpredictable.
Over in the high-stakes world of finance and economics, professionals are constantly trying to tame volatility. They literally use stochastic calculus, which is essentially the math of probability, to find patterns in what looks to the rest of us like total economic randomness. This ultimately protects investments and global markets. They're relying heavily on partial differential equations to model price dynamics and evaluate risks that would otherwise seem completely impossible to measure.
Meanwhile, meteorologists face a very similar challenge when dealing with the weather. To predict severe storms or model chaotic, long-term climate systems, they turn to fluid dynamics and things like the continuity equation. They have supercomputers running these equations across incredibly complex 3D grid systems of the atmosphere. They are constantly calculating pressure and fluid motion to predict exactly where a hurricane might make landfall.
Section 4. The Hidden Force of Nature.
Now, you might not normally associate farming with heavy mathematics, but from a small home garden all the way up to massive agricultural operations, math is what turns effort into efficiency. Modern farmers are essentially acting as data scientists today. They leverage mathematical modeling, meticulously tracking weather averages, checking soil pH levels, and using highly accurate unit conversions to ensure the correct inputs and dosages for their crops. They even use geometry to map out massive farm dimensions to fully maximize their land use.
And they do all of this to achieve very strict financial outcomes. They have to balance every single variable, from crop yields to variable costs. Hitting a precise ROI, like 53.2%, isn't just the result of a lucky harvest. It is precision math driving sustainable farming. This kind of data-driven decision-making drastically minimizes their losses and improves their overall success rate.
Section 5. The Universal Language. When you finally step back and look at all of this together, you might just have a bit of an epiphany. When you realize that the exact same partial differential equations running a video game's fluid physics are also out there securing cyberspace through cryptography, optimizing crop yields, and predicting the stock market, it just clicks. Everything suddenly makes sense. It is literally like finally seeing the underlying code of the Matrix. You're getting a true glimpse at the fundamental symmetrical nature of the universe itself.
And that brings us to the deepest, most mind-bending mystery of all. If mathematics is rooted in logic that was invented by humans just for curiosity, why is it able to so perfectly decode and predict the physical reality of the entire universe? I'll leave you to think about that.
Make sure to like and subscribe for more videos like this.